we've got a quick fire talk now to complete our evening as we head up to the hour. And it's my great pleasure to welcome back Matt Eustace, who we met at the beginning of today's session. Matt's at Aiimi, so he's using technology to mitigate risks, solve privacy compliance challenges, particularly in regulated industries and public sector organizations. He's had a 20-year career. He's worked with global technology vendors, founding member of data and AI company with Aiimi, of course, and a Privacy-whizz, he mentions as well. So he's been helping organizations get started with advanced content, data analytics products, targeted at finding and disclosing information in response to requests like FOI and DSARs. It's my great pleasure to welcome a 15-minute talk from Matt that will take us up to a few minutes before the hour, where I'll sign us off for the evening. The stage is very much yours, Matt. It's very wonderful to see you.
Thank you very much, Richard. So I'm not an AI ethicist, so I'm going to concentrate on the things that I know well, which is the work that we do with using AI technologies to solve problems of disclosure. So when I was looking at the event tonight, I was thinking about how a lot of focus will be on the way that we have to disclose what AI is doing, particularly when it's being used to take elements of data about us and then making decisions about what we should or shouldn't be offered in terms of adverts or even in other situations not offered. And I thought I'd flip that on its head and talk about how we can use and how we do use AI, machine learning, statistical modeling, those kind of things for helping solve some of the problems with the huge data sets that we're faced with nowadays when it comes to disclosing information that people are asking for, whether that's for a business purpose or whether that's a data subject, a person who's actually saying, can you tell me what you know about me and how you're using that information. So the problems that we face when we're trying to do that kind of thing, they're really, there's a number of them. Most of them are about the size of the data, the size and complexity of the data that we look at in modern organizations when they're holding information about people. And the problem that represents depends on the kind of data it is. So organizations that are using structured data systems and they're dealing with customer data and holding that in databases that are accessed by a front-end system usually have quite good ways of finding that information and disclosing it. So the structured data represents a relatively small problem. We then move on to the slightly more complex problem of the data that's held in documents. So that's a bit more unstructured. There can be large amounts of it, a lot to trawl through. And then there is the huge problem of the chaotic information that's stored in social media platforms and email and things like that. That represents a traditionally very difficult problem to mine, a data set to mine, that is really only accessible and can be dealt with using AI platforms, machine learning, etc., to help us work through that. So we can use a number of different techniques to try and address those, which I'll talk a little bit through about how we use those. We others who deal with this kind of problem tend to use a combination of different techniques, everything from simple algorithmic approaches right the way through to much more complex AI-driven approaches for extracting information and deriving meaning from it when it's organized in these large data sets. So challenge one, the sheer volume of data that there might be that you need to look through. So as we go through this, I'll really use the example of a subject access request, but I'll refer to other reasons why you might want to be going through large data sets to try and find information and extract that and disclose it. But really, if you try to do that manually, looking at an enormous data set, it's very difficult to ask the right questions of that data in a consistent way and get a complete, holistic, trustworthy response in a reasonable amount of time that you can then disclose to people who are asking for that information. And it's difficult also to ask very simple questions and get the right answer back. You can imagine that if you're looking for subject A's data and you just said, show me everything about subject A, and that person was an ex-employee, you're likely to get back an awful lot of information, which is not actually personal data, it's just things that they've authored. and you're going to miss the things that are really key. The other problem with the diversity of data is that if you need to service a subject access request or any other kind of information disclosure, you're going to have to involve a lot of people, because there are a lot of different systems out there that store the information in different ways. So you're asking a number of people to access different systems containing different data and try and make a consistent decision on whether something constitutes a piece of personal data that needs to be disclosed to the requester. So you're having to educate people and distribute the task amongst many people before you can collate a response. You've then got the collation point on top of that. So it's a fair amount of effort. The challenges that we need to try and address when we're using AI and ML and other technologies to solve this problem. One of the big problems that we've got as well, which we come across a lot in our work where we help implement data systems and content management platforms and things like that for organizations, is that data is not always in the right place. You can have the box and it might be labeled and say this is where all personal data is, but actually it's not there. People aren't storing things where they're supposed to be stored. They're storing them elsewhere, not properly catalogued and labeled. So when you look for things, you think you've found everything, you think you've disclosed everything, but actually the goal that you're after is in a different box entirely. And that problem of educating people to do things correctly is something that is always going to have exceptions to it. So you need to be able to use modern technologies to try and account for the fact that people make mistakes in what they're doing. So how does AI and ML help us to address those kind of problems? Well, the first thing that we need to do is we need to be able to access data in a consistent way from different sources. So we use various techniques to extract data from structured data sources, unstructured data sources, and put that into a meaningful format. In which case, in this case, we're really talking about the textual evidence from those source systems and putting that into a consistent index of just the text that comes from those. We'll talk a little bit more maybe about other information sources like visual later on. But in terms of when we're looking for people's information, we're really majority of the time looking for text-based information. So we need to standardize that. We then need to use different mechanisms for extracting interesting information from that, because there's an awful lot of stuff there that we're not really interested in and that can muddy the water in terms of responding correctly to a request. So some examples of that: named entity recognition. Pamela talked about mistakes in models, model errors. NER is a really interesting area to look at the information that NER models give back to you when you try and use them to extract information. So an NER model will usually be used to help you find people, names of organizations and places, and they can get things spectacularly wrong. But on the plus side, when we're playing with them and using different ones, we get to look at all the interesting names. I think it's the same people that name Android versions that name NER models, and we have managed to find some good results from these. So that's the first thing that we do. Next thing is that you're interested in particular pieces of content text that are relevant to a disclosure. So if you're thinking about GDPR, personal data, and those kind of disclosures, there are standard lists of information that you would want to compare that text to and find matches for. So medical conditions, titles, genders, those kind of things. They're all examples of dictionary lists, and we use those to just make straightforward, simple matches. Regular expressions, we're looking for patterns, so we can find people's email addresses, national insurance numbers, driving license numbers, those kind of things. And then one other thing that we might want to do is look at statistical analysis, so we can use that to pull out the topics that are being discussed in information to decide whether a document is a particular class of document, or a piece of data is a particular class of data, and it has a particular theme. And we can use that later on. We'll talk about weighting when we talk about disclosure. So once we've used various different mechanisms to get that data out, what we can do is we can classify the original content, and we can say, okay, this particular piece of text, this document, this data record from a system This is about Joe Bloggs. It has a national insurance number in it, date of birth, bank account, etc. This next document's only got a name in it. We're not really interested in that. There's no personal data in there. We don't class the name as a piece of personal data unless it's in conjunction with other things. And then the third item, that's actually also something that's relevant. If you were just doing this, as I said earlier, with a search for a person's name, you would get everything back. It would be a huge amount of information to run through. So these different models will help us pick out relevant information and then actually refine our search down to the right personal data to disclose. So that gives us an answer to the problem of mining for the right information, and it gives us a standardized way of grabbing that data. But we have now still got a data set to go through. So this is where we get into the world of weighting and actually using real AI to apply weightings to information so that we can make sure that we focus our effort on analysing, reviewing the right documentation, and then maybe just giving cursory scans to other information, because we're pretty sure, pretty confident on the basis of the weighting that's being given that we've got the right information to disclose. Weightings can be made up from different factors, so potentially the number of different items of personal data that have been found there. The sensitivity of that information, so we can respond when we're thinking about dictionary listing and weighting the weighting algorithms that we use. We can respond to changes in society for things like diversity information that is increasingly important to people when they're considering what constitutes personal data. We can make the weighting respond to that. We can apply different sensitivity weightings to different kinds of information. And then we can also use AI to understand from the classifications of documents that or data sets that we talked about earlier, how frequently particular types of data is being disclosed. And then we can give that a higher weighting based upon the fact that that kind of information has been disclosed in response to a subject access request many times in the past. So that can then be used to refine our weighting. So if we look at a statistical model of the information that's being disclosed, we can attempt to classify that with different algorithms. We can find groups of information, and that tells us, yeah, all the pink dots, they're things which we nearly always disclose. All the yellow dots, they're things that we usually don't disclose because they're not really relevant. And then we've got some outliers. So we can use some interesting newer technologies to try and train those models, and we can use potentially different models and optimize those so that we get better matches for the information that we do or do not disclose. This is an interesting area in terms of the ethics of these kind of things, because those platforms tend to be service-based platforms that can do automated model training or automated model selection. So that's something that gives us pause for thought when we're thinking about what technologies we use to enhance this process. But basically the outcome of this is that we can use these technologies to make very clear decisions that some information definitely relates to a particular individual. It definitely contains personal sensitive data. We definitely need to disclose it. Others definitely doesn't. And then there's some middle ground parts in the middle, which needs a bit more human interaction. Named entity recognition plays quite a good part in this, because the pieces of information that need to be checked and possibly redacted as well when you're thinking about these kind of disclosure processes are where it's not just the individual making the subject access request that's mentioned, but also other individuals, other companies, organizations. So that can be highlighted by these kind of software systems, so that you spend some time looking at that and making sure that you're enforcing the privacy of your other subjects that might be mentioned. Just to give you an idea of what this might mean in terms of the use of these kind of technologies. Different example, this isn't a subject access request, but using these kind of models to classify information and make groupings of information available to people who are assessing the risk that something contains personal data, or in this case, export controlled data. We're working with an organization that was trying to analyze a corpus of 200,000 documents in order to be able to disclose that to a new joint venture. Took them down from 35 minutes to 5 minutes per document review, and auto-classified about 75% of the content. So that gave them a 78 person year to a 2.7 person year problem. So obviously with these kind of technologies, the new problems become solvable that weren't previously solvable in a manual way. Okay, just to wrap up, trying to bring back some of the points that we heard earlier. Training data sets that Nikita mentioned, one of the things that we worry about are when people want to use external auto ML, auto machine learning classification technologies that might be service-based and might be used on the fly. It's quite an interesting challenge, that, because you need to be able to send out data and have that analyzed externally potentially, and then change a model based on that. You're effectively using live data for training, and that's a difficult problem that we come across and we need to think about. So on the fly, anonymization, those kind of things becomes a concern for us. I think we're running close to time, so I'm going to stop there.
Thanks so much, Matt. And I think this is really interesting and impressive what you have shown, especially the case study. And it is important to realize that when the data flows from the back end to the front end and the different formats the systems could hold, and bringing it to consistency so that you could have a data disclosure that can be understood at the business level is so important. And using certain techniques like you mentioned about the dictionary lists, the regex, or the statistical analysis, I think is going to be important, and doing the weighting mechanisms that you have shown would definitely work, because we do talk about ethics, but there have to be tool sets behind it in order to run them and make data disclosure possible technically, and tying it back to personal data is really going to be important. Thank you once again.